Hello everyone and welcome back to the channel. Today we're journeying to the heart of one of North America's most spectacular landscapes, Yellowstone National Park. But we're not just here for the geysers and the wildlife. We're going deep underground to explore a force of nature so immense it boggles the mind, the Yellowstone Supervolcano. And we're going to answer a question that might be on your mind. With all the earthquakes happening there, is it about to blow? Yellowstone National Park is famous for its geothermal wonders. Old Faithful, the Grand Prismatic Spring, these are all surface expressions of a massive heat source lurking beneath. This heat source is a giant magma chamber, the heart of the Yellowstone Supervolcano. This isn't your typical cone-shaped volcano like Mount St. Helens. A supervolcano is a vast depression in the ground, called a caldera, formed after a colossal eruption empties a magma chamber, causing the ground above to collapse. The current Yellowstone caldera is enormous, measuring about 30 by 45 miles, and it was formed during the last super eruption around 631,000 years ago. Now let's talk about the shaking. Yellowstone is one of the most seismically active areas in the United States. It experiences between 1,000 and 3,000 earthquakes every single year. Most of these are too small for us to feel, but they are constantly monitored by scientists at the Yellowstone Volcano Observatory, a partnership between the U.S. Geological Survey, the University of Utah, and the National Park Service. So why all the tremors? It's not just one single cause. Yellowstone sits at the intersection of several complex geological forces. The primary driver is the movement of tectonic plates. The entire basin and range province, which stretches across the western U.S., is slowly being pulled apart. This crustal stretching creates faults, which are fractures in the rock. When stress builds up along these faults and is suddenly released, we get an earthquake. The majority of Yellowstone's earthquakes are related to these pre-existing faults. Think of it like a network of cracks in a pane of glass. Stress will always find the weakest points to release. The Hebgen Lake earthquake in 1959, the largest in the region's recorded history, with a magnitude of 7.3, was a powerful example of this tectonic activity. But that's only part of the story. The volcano itself is a major contributor. The magma chamber isn't just a static pool of molten rock, it's a dynamic system. Hot fluids, water, steam, and volcanic gases like carbon dioxide and sulfur dioxide are constantly moving through the rock deep underground. This movement can create pressure changes that stress the surrounding rock, triggering small earthquakes. Imagine a complex plumbing system full of hot, pressurized water. As that water forces its way through tiny cracks and fissures, it can cause the rock to shift and fracture, creating what we call hydrothermal-related seismicity. These are often the culprits behind the earthquake swarms Yellowstone is famous for. An earthquake swarm is a series of many low-magnitude earthquakes occurring in a concentrated area over a period of days, weeks, or even months, without a clear main shock. Yellowstone experiences these swarms frequently. For instance, in 2017, a swarm under Yellowstone Lake lasted for months and included over 2,400 individual quakes. Now I know what you're thinking. A swarm of thousands of earthquakes under a supervolcano sounds terrifying. It must be a sign that magma is on the move and an eruption is imminent, right? Well, not necessarily. This is where it gets interesting. While it's true that the movement of magma can cause earthquake swarms, a process called magmatic intrusion, this is actually the least common cause of swarms at Yellowstone. Scientists can differentiate between these types of seismic events. Earthquakes caused by magma tend to have a different seismic signature and are often accompanied by other signals, like significant ground deformation, the ground literally swelling up, and changes in gas emissions. The Yellowstone Volcano Observatory monitors the park with an incredible array of instruments. GPS stations measure ground movement down to the millimeter. Seismometers record every tiny tremor. Gas sensors sniff the air for volcanic compounds, and thermal sensors monitor heat flow from the ground and in the lakes. All this data creates a comprehensive picture of the volcano's health. And what this data tells us is that the vast majority of Yellowstone's earthquake swarms are caused by the movement of hot water and gases, not magma. It's the volcano's plumbing system letting off steam, not the magma chamber getting ready to erupt. this constant low-level activity is actually a sign of a stable, albeit active system. It's the volcano's way of breathing. So, what would a real pre-eruption sequence look like? Based on studies of other calderas around the world, scientists have a good idea of the warning signs. We would expect to see intense and escalating earthquake swarms, with quakes getting stronger and shallower over time. We would see dramatic ground uplift, far greater than the few centimeters of rise and fall that happen annually. We'd also likely see huge changes in the geothermal system, with new geysers and steam vents appearing, and significant changes in the chemical composition of gases being released. Crucially, all these signs would happen together, creating a pattern of escalating unrest that would be unmistakable to the monitoring teams. This kind of activity would likely go on for weeks, months, or even years before an eruption. It would not be a surprise. The chances of a super eruption in our lifetime are incredibly small. In conclusion, the constant seismic hum of Yellowstone isn't a sign of impending doom. It's the sound of a living, breathing geological wonder. The thousands of yearly earthquakes are a normal and essential part of the life cycle of this complex volcanic system, primarily driven by regional tectonic forces and the volcano's own hydrothermal plumbing. Scientists are watching 24/7, and they have the tools to give us ample warning if the situation were to change. So, the next time you hear about an earthquake swarm at Yellowstone, you can think of it not as a countdown to catastrophe, but as a fascinating glimpse into the powerful forces that shape our planet, a reminder of the dynamic world simmering just beneath our feet. Thank you so much for joining me on this deep dive into Yellowstone's seismic secrets. If you found this video interesting, please give it a thumbs up and consider subscribing for more science content. Let me know in the comments if you have any other geological mysteries you'd like me to explore. Until next time, stay curious.